know every cell in your body at this very moment is running a code? Imagine if you had the power to change this code, the blueprint of your very existence, the code that sculpts your eyes, your height, your mind, your resilience. What would you change? I asked myself this very question, and I vividly remember the day the answer unfolded before my eyes. Because for some, that change is not based on imagination, it's a matter of survival. Raise your hand if you've known someone who's had cancer. I've known someone too, a close friend of mine. She was battling lymphoma. Chemo failed, radiation failed, hope was slipping away. Then came a final chance, a clinical trial. Her immune cells were removed from her body, programmed in a lab with new DNA, and infused back, now trained to find and kill the cancer. Months later, she walked into my lab, alive. It had worked. I had watched my friend's life hang by a thread and saw how a string of DNA had changed everything. In that instant, science became no longer an abstract pursuit, but was a force that could rewrite destiny. It wasn't just lines of code on a screen or colored liquid inside a test tube. It had been her second chance at life. Suddenly, it became urgent, personal, human. I realized that science can rewrite life itself. That moment shattered my view that biology is rigid, static, unchangeable. I began to see modern biology as a living script, lines of code that can be edited. Edited to change the course of disease, edited to change the way I think, edited to change humanity perhaps. DNA is the code of life. Digital. Cut, paste, copy, replace, editable, customizable. Our cells are like delivery agents, trained to perform specific function, hunt down targets, adopt even new identities. Imagine using your favorite delivery app to order a gene or a cell to change your height or your body type in the future. It isn't that far-fetched. Today, we stand at the threshold of a profound shift. Our understanding of biology is changing. We are not just understanding life, but we are moving towards something far more powerful, programming it. Cells function like sophisticated software. Process inputs, make decisions, generate outputs. And much like sophisticated software run a set of precise instructions, cells encode genetic programs that dictate their behavior. Now, with this insight, we no longer are passive observers of evolution, but we can become co-authors of it. But unlike a simple code, the cell runs a very complex network inside it. So we need a systems level view, a big picture understanding, a holistic understanding to truly reprogram life. To decode this big picture, my group at the National Chemical Laboratory in NCL pioneers a systems approach to understand reprogramming in disease. Now, diseases aren't isolated glitches in single cells. They arise due to disruptions in networks of interaction. Much like an orchestra, one discordant instrument that's out of tune can completely ruin the symphony. We map out how molecules interact across the entire cellular network, much like creating a citywide traffic map of the biochemistry inside the cell. We can thus spot bottlenecks and redivert flows when needed. There is an urgent need for this systemic approach because the cell is a complex system. It's made of multiple components that not only interact with each other, but also with the environment. Let's take glioblastoma, one of the deadliest brain cancers. It's notorious for resisting therapy, drug resistance. Let me demystify how my lab tackles this. I want you to picture a bustling city. Cars, buses, bikes, bustling around, moving through very busy streets. Now imagine that one of the major roads is closed. Chaos follows while traffic reroutes itself. The cell's network is like a city's traffic system. The cell's network is like a city's traffic system. The molecules are the car and the pathways are the streets. Now, cancer cells can hijack this system and open and close roads unpredictably and therefore rediverting molecular traffic. What our systems approach does is identifies these diversions quickly and reverts them back to the original state. This makes cancer move from being a rigid black box into a programmable system. One telltale sign of this hijack is the accumulation of a molecule called NADH, which normally carries energy and charge. This causes the cell's battery to overload and thus causes systemic instability. It's like your cell phone charging too fast and heating up. There is a critical need to identify these energy jams because identifying them allows us to intervene by boosting enzymes like NADH oxidase that make intramolecular conversions possible, release the jam, and restore the balance. But how do we do this inside the cell? How do we fight back? Who are our traffic police? Meet GEMs, genetically encoded metabolic manipulators and sensors. Tiny gene circuits that can be delivered inside cells to reprogram them. We design these genetic circuits so that they can reduce NADH accumulation and thus reduce resistance. So think of them as molecular smoke detectors connected to automatic sprinklers. When danger pops up, they spring into action. And voila, the cancer cell responds to the drugs again. GEMs are DNA-based living therapies designed and made using molecular text editors like CRISPR and synthetic biology tools that make them modular like Lego bricks. This allows us to quickly release feature packs, much like software updates, and stay ahead of cancer's game. This is precision engineering. It shifts treatment strategies from a one-time assault to a smart adaptive defense with lasting control against any deadly disease. Our systems approach allows the cancer cell's dirtiest tricks to become its own Achilles heel. Now, if I had to rewrite a code, it would be this, that a diagnosis for brain cancer comes not with a countdown to despair, but with an engineered solution of optimism. Born not out of wishful thinking, but out of a flask, a cell line, a DNA, where every single cell can be reprogrammed to respond to therapy, creating lasting hope and health. Exciting, isn't this? You are at the brink, the very edge of not just redesigning life, but controlling it. Now, the tools and the power of systems thinking is not restricted to only understanding disease. It can be used to tackle many problems like sustainability, climate change, and even the bioeconomy. Cells today can perform very complex tasks. You can engineer bacteria to turn light bulbs on and off. The tools of systems and synthetic biology can now bend to human creativity in such a way that you can innovate and engineer endlessly with DNA. Let us talk a little more about sustainability. You hear about the dwindling petroleum reserves. You distress over climate change. You dream of a cleaner and greener planet. Let me show you a glimpse of an incredible world that is unfolding before us to realize this dream. The same tools we use to reprogram cancer cells can be used to make sustainable biofactories, microbial cell factories that allow us to support our growing needs, slash our dependency on fossil fuels, and cut carbon emissions. These living factories can be precision engineered to make fuels, food flavors, food also, and also any kind of material, all from renewable resources, operating at room temperature, and creating minimal waste. My lab, among other things, engineers microbial strains to make a compound called violacin, which is a stunning purple pigment which also has antimicrobial properties. Imagine wearing antibacterial clothes in the future. We also engineer bacteria to make vanillin, the molecule behind the iconic vanilla flavor, to ensure that we all have high quality organic vanilla without deforestation. We also design microbes to make biodegradable plastics that are environmentally friendly and will not choke our oceans. We also attempt re-engineering life-saving drugs like penicillin, smartly designed so that bacteria do not outsmart them and reduce the risk of antibiotic resistance. Now, each of these innovations is a testament to the power of reprogramming life itself. I often joke that my bacteria are better multitaskers than I am. These projects aren't just scientific exercises, but they are prototypes for a bioeconomy where materials, medicines, chemicals can all be grown in sustainable fermenters. Think about it. This is synthetic biology rewriting products and rebuilding global supply chains. From the toothpaste you use in the morning to the pills you pop in at night, all of these can now be consciously designed using this technology, making it affordable and accessible. We have the unprecedented ability to transform our environment, creating a world that is not just inherited, but intentionally designed. This isn't science fiction. This is science in action. But where does all this lead? While these advances open up breathtaking opportunities for life, second chances at life, and creating sustainable futures, they pose many profound questions. What happens when you cure aging? Who gets to live longer and why? Indeed, with great power comes great responsibility. Let us explore the concept of genetic personalization before birth, a concept you probably know as designer babies. Picture a world where parents are not just choosing for avoiding genetic diseases like Down syndrome, but selecting genes for taller heights, eye color, and sharper minds. How far is too far? Will the ability to choose a child's gender bring back old biases in new high-tech ways? Will editing for enhancements remain a luxury only for the rich and thus deepen our social divides? Might we erase the rich tapestry of human diversity in the pursuit of a narrow idea of perfection? The answer lies with you and me in public awareness, open dialogue, and responsible governance. We need not just brilliant minds, but engaged citizens and thoughtful leaders, while our responsibility shifts from being just observers of life to its architects. Because it's not just about editing DNA, it's about editing our future, perhaps for a perfect tomorrow. So as you leave here today, I want you to remember the cells in our body, the microbes in the soil, even the very code of life. They are not just mysteries to admire, but they are circuits you can program, instruments you can tune, impressions you can make. We are at the dawn of a biological renaissance, where DNA is the code and we are the new storytellers. We are the first generation in human history to hold the power to program life itself. And you do not need a lab coat to be in here. You're already inside this story. So step into the moment, for the blueprint is open, the cursor is blinking, and the next line is yours to write. Thank you.